Hi y'all, I'm going to teach you a little bit about what I'm learning in econometrics, environmental econometrics. So we're looking at the school quality between Berkeley and Richmond. And so we're going to use a regression discontinuity with the application of like a treatment of local average treatment effect. So local average treatment effect is known as late, and in this problem we have two different locations, and so like depending on the schools, like let's say Berkeley performs better than Richmond, we're trying to see if Berkeley, for example, the people there are thriving, and like do Richmond people try to move in closer to Berkeley to be able to be considered within the school district. Now when you're looking at this through the lens of like econometrics, I suppose you're seeing the distance between this boundary, the two different like this intersection boundary of like, okay, all these students will be cut off and going to the Berkeley district and the other students won't. So you have this kind of equation where it's log price minus beta 0 plus beta 1, Berkeley 1, plus beta 2, distance from the boundary, plus beta 3, Berkeley, and the relationship between the distance and the boundaries, plus U for noise. So for those who don't understand, there's this immense equation where you can kind of look at the curvature. We log the price because price can go everywhere, and so to make it like stabilized, you just log it. And so we consider like if we held all constant, which is beta 0, plus the coefficient beta 1, with the influence of like Berkeley's performance, plus the distance from the boundary and the coefficient. So and then lastly there's the relationship with the boundary and the school. So that would consider both of them. So here we are talking about three different variables: Berkeley, distance from boundary, Berkeley, and distance from boundary. And we're going to see that if there is a distinct difference or continuity between the two. So the performance of the children, identifying like, okay, so the question asks, what coefficient estimates the treatment effect? What type of treatment effect does this model estimate? And it says B1 estimates the local average treatment effect. That's like the answer. I personally don't understand that yet, but explaining to you kind of helps me come back to this and maybe figure that out later. But there's something with beta 1, B1, that if the home is on Berkeley, the southern side of the school district boundary, and there's and distance from boundary minus L latitude minus C measures the distance in degree latitude between home I and the school district boundary position C. That was jargon. If you didn't understand that, I didn't either, and that's fine. So we just keep moving. When we're learning, we're just kind of like absorbing, and we'll question the things as we go, and maybe eventually at some point it'll click. That's how I work. So B, what is the key identifying assumption for this model? And the answer is that the relationship between the distance and housing prices would otherwise be continuous around Berkeley and Richmond's border. If it were not for the difference in the school quality, then across these, if they were not for the difference in school quality across these two school districts. But if there was, there would be a discontinuity, which essentially means that like it's testing if the school quality differs between each cities. And when we plot the difference, the relationship between the home sizes and the distance from the school cutoff, there's a graph that looks like this, and it says from bottom to top, this is like the home size increasing, and this is distance from the boundary. And essentially there's like an absolute value chart right here that says Berkeley side of the boundary, the houses are bigger, and then it slowly gets smaller as you get closer to this boundary, which I assume is where the school is. And then Richmond, like it's smaller and then it grows bigger, like the cost. So it asked me, what does the plot tell you about the validity of your estimator? And I have no idea what does validity mean. So I'm asking ChatGPT what does validity mean, and it says validity of an estimator refers to how well it approximates the parameters it's estimating. Unbiasedness, consistency, efficiency, and asymmetric normality. So ensuring the validity of an estimator is critical or crucial for making reliable inferences about the population parameters based on sample data. So all of that to say is that I don't know anything, and I'm still trying to figure it out, but that was taught during discussion today, which I missed. So I'm teaching myself all these things, and RDD is the regression discontinuity late. So we are only comparing people just above and below this threshold. So treatment of effect from RD analysis is only applicable to individuals that are around the threshold. Okay, so I think they said C is the school district boundary position. What is... Okay, so school district boundary position means the geographic delineation or demarcation. Okay, fuck, I don't know how to pronounce these words. That define the jurisdictional area of a particular school. School district boundaries are established by educational authorities or government entities and serve to organize and administer public education within a specific geographic area. Okay, essentially it's like redlining for schools. Cancel them if you want, but like, for example, if you're in a rich area, all the rich kids will go into this rich school that is within that location, and they have these like PTOs or like parent information where the parents will directly support their students, versus if you're in a poor district and the parents are more of a working class, so they can't get involved with their kids as much. Therefore, the education is not as well, there's less involvement, less funding, and so on. And so this is a chronic problem within the states of, at least in California, where like I myself went to a district with wealthier white kids in order to get a higher education, and there's often like barriers to this, like for example changing your address or moving in with a different family member, or like performing very well, like spectacular, and getting in by yourself. And for me, I didn't get to do those things, and I was just like, I transferred. I said that my cousin went there, which was true at the time, and like I got into this district that was considered like Berkeley. And so all these little like pedestals that I've been doing, like going to these middle schools and like performing at best, has been impactful. Now that I'm learning this in classes like RDD and being able to measure these things is quite eye-opening, because I never thought that I don't know what WTP stands for, but it says it's showing the regression discontinuity treatment. Anyways, that is all that I wanted to share. Regression discontinuity design. Anyways, that's all that I have for y'all. I know it was completely confusing. I'm just as confused. Thanks for trying to listen to me as I try to teach myself and reflect on these things. Bye. See you later. Also, this is the library. It's super cool. You were probably looking at these columns, and they're really cool. Okay, bye.